Welcome, I'm Bill Wake. We're here working on a programming language called Tenth, and our focus is implementing it in assembly language using a technique called threaded interpreters. Now, the language itself uses the idea of a data stack. So it's much like Forth, where arguments and so on are on the stack and we manipulate the stack. I thought I'd lay out the stuff that's in the virtual machine. There's probably more that I haven't thought of yet, but one thing I know we have is a dictionary. So if you need to find definitions for the words or you're defining new words and they need to be looked up at some point, you go through the dictionary and find them. The second piece is, well, I'll take the one on the bottom. The system stack is what keeps track of the addresses and the program counter as you're calling subroutines. And then the data stack is the stack that the Forth-like language will manipulate, pushing things and popping them and so on. So I'm imagining some sort of registers that we have, and we can probably just allocate them kind of permanently to these pointers. One is the virtual PC. So we mentioned last week our secondaries have a list of functions to call, and something's got to keep track of where it is in the list. So that's the VPC. And then a virtual stack pointer for the data stack. We'll also make use of the PC program counter. If you're going anywhere, you got to use that. The stack pointer, because we're making procedure calls and pushing things on the stack. And the link register, which points to where the return address is. All right, so we'll start introducing elements of that today, at least the virtual stack pointer and the actual stack memory. All right, and then I just started laying out some vocabulary things. I just took Forth ones, and if they made sense, I kept them, and if I wanted to change them, I changed them. No particular, I'm not particularly attached to them. Okay, so but there's a couple for memory. There's logical operators. The focus today, we're going to do push, and then I think over on arithmetic we'll do add. So we've already done NL, which is new line, on the IO section, bottom of column 2 there. That takes 0 arguments on the stack. Push is going to push 1 argument on the stack, and then arithmetic is going to take 2 off the stack and push 1 on. So that'll give us a flavor across of many of the routines we need to get things moving. I mean, if we can implement plus, we can implement minus, and so on. There's nothing special about them. I don't think the memory one, that will introduce some things. I'm not quite sure what to do there. And then some control statements. Again, I'm not quite sure on the words, but if, else, end, if, maybe, I don't know, loop, flag, while, maybe while, end, while, or something. Just working around ones I've seen. Okay, repeat until, that's pretty normal. For next, if we want to do a counter kind of thing. We'll see. All right. Now, as I was doing the summary this last week, which I haven't uploaded yet here, it's on YouTube, I noticed our print statement uses X10, and that's not actually legal, or it can't assume it's going to be there for it. Let's see if I can get, I guess that's under Unix function. Nope. Not macros. Did we put it on C-like? That's the test. Oh, we did. Okay. Yeah, so in here we use X10. Is that right? Print. Okay. Yeah, we use X10 to keep an extra copy of the address. And way back in our first couple of days, we had register allocation. X10 is a temp register, so the local routine is allowed to modify it without worrying about keeping it around. I think we want to use something more in the X19 to X28 layer, because those are guaranteed. If you use them, the callee, the thing you're calling will save them and restore them if they're used. Okay, so let's just pick X28 and change it to that. Now, that introduces another problem. that we need to store X28 as well as the link register. Now, let's see if we can find the syntax for this. It's somewhere. I thought it was like braces and you put the thing in. I don't know. But I'm pretty sure you can store a bunch of registers at once, or at least two. Store instruction. Store WT 32-bit name. That seems weird. Store the right instruction? Store register calculates an address from a base register value and immediate offset and stores a 32-bit or 64-bit word from a register. Okay, I guess we want the 64-bit. I guess these are combinations. Index width. Okay. Well, I think because we're naming our register X, that doesn't quite fit how I think of it. For what that's worth. Let's see this one. I have the book by Smith, and he recommended this site that has the exercise or the demo code all worked out for the Mac situation, so slightly different. Let's see, there's program flow. Somewhere there's going to be a chapter on calling. Oh my, he does do a bunch of stores. Okay. Which is the alignment. Okay, well, I think yeah, I mean, I feel like we should be able to do both these in one instruction because the stack has to be done two at a time. X3. I mean, he manipulates it like that. First, we go the stack downwards 32 bytes to make room for 3 64-bit values. We're creating space for a fourth one. Okay, so that's number of bytes. We did 16, right? Because I'm sorry, I keep bringing that up. Okay, we did 16 because we're doing that to make it. So it sounds like we can one double word above. Okay. So that pushes that 2 at the current SP and moves it forward 16, but we actually have room for another. Now this is not SP plus 8. Oh, and I've forgotten what that bang does. Is that auto? It's pre-increment. Okay, so I believe we can do this. Except I feel like something's not right there. Yeah, we had to keep track. Feast Mia. Okay. Yeah, I thought that was one where you put the list of variables or registers. Well, that's not quite where we are. Store multiple SIMD and FP registers. Okay, we don't really care about those. All right, let me go back to this. He just throws it away. I gotta look at addressing modes again. I think we want this one. RN value. But the second one is incrementing. We're just trying to access 8 bytes in. Okay, let's run this. I guess our normal run should do it. Let's do make clean. Make C like tests dot C like tests. Let's just do make clean. Make. Okay. Oh, no, we want the other one. Okay, it does still print. We'll have to pay attention. I don't want to try and... Yeah, I really don't want to try and test the print statement directly. Right, let's change this. Maybe we can do something in those tests though. And these are kind of very temporary. Yeah, let's make a test. Okay. That just does some printing. test print. Okay, so what I want to do is very much like this, but I want to assert, so I want to, doing that in there, assert BL print. Yeah, I want to assert that, I want to set the value of x28, move x28 pound 42. Okay. And then at the end, after the print, I want to assert x1 says the result. Well, let's move x0 equals x28. That should still be 42. And we'll branch move x2 LTS test print and BL assert equal. Yeah, okay, and I think these two we'll turn off for a moment. And they're all just kind of scratch tests, I guess. But I'm going to do this one just to make sure we get things straight. Unknown fix-up kind. How is that any different? L underscore TS underscore test print. Oh, ADR. Well, my make should do the right thing from this. Okay. All right, this should pass. Okay. Okay. So our X28 is restored. All right, good. I don't think we'll need to do a lot of pushing because we're not gonna let things. We just won't have that many registers we need. Hopefully, one's the most. Okay. Let's see. So, yeah, that doesn't work. Make print use x28, verify that x28 is restored. Okay. And I did go in, well, I thought I went in. I did touch a bunch of files to kind of get rid of extra spaces and make them lowercase. We'll see how many more I missed. Okay, to do print this. All right, so that goes on today. Now, I want to do a push. Okay. So, well, I guess let's just make a test. This is core. And we're keeping this idea around, but I don't see a core test. So let's add that. I don't know why that's popping in new. Okay, and I'm going to copy. Well, I suppose I could do that. kind of make a separate run application. Okay, so that's going to call the methods we have yet to define. Okay, so we'll take some. Okay, so I think we'll use a little. So I think what we'll do, kind of going back to this picture today, I want to assign, like, I don't know, X20 to the VPC, X19. I don't know. I'll put them in the other order. I'm thinking this one's X19 as a global, in effect, and X20. And we're going to say our code will only touch them if it's actively manipulating them. So the push, right, is going to update the stack pointer for sure. Okay, and actually it's going to update the virtual PC as well. So I don't know where I guess I'll make a new page here. And a slide. Okay, so kind of a before and after. Let's take this. Okay, so before. Okay, and then our code is going to live somewhere in a secondary in general. These pushes, they're for the benefit of the secondaries. So it's going to look kind of like this. I think I can take off that top kind of little piece there. Okay, so in here, there's going to be a push. And I'm going to put these with capitals. I don't know if we want to write them that way or not. Too helpful. All right, let's have a push, and then the number is going to be following it. So this is like an instruction, but it's got a parameter. And there aren't a lot of those, but I think we have to start. We have some of them somewhere. So I think, this push example is going to be good for that. Plus, we need something to get things there for arithmetic. But in your list of secondaries, what I call this one was end. Well, let's say we did add. Okay, we'll take all three of these. Oops. Okay, and then we had our, I think we called it end two or something. Where is it? Wasn't notes in here. N2D. Okay, so I'm sort of assuming the presence of that. N2D. Okay. So let's suppose this represents a function that adds 142 to something. I don't know. Not a very meaningful example, but this is what we got. So there's something on the stack, and we're going to push 142 and then call add, and then we're going to return. And whatever's the sum is left on the stack. And so the virtual PC is pointing to push. Okay. Let's see, can I do this? Yeah, pointing to push, and the stack is pointing, here. That one I have. Okay. Let's say the stack is here, and we've got, 8 on the stack. Okay, and there's probably some other stuff down beneath it. Okay, here we go. So when you execute this, it's supposed to push 142 onto the stack, 142, and then the add says, oh, it's 8 plus 142 is 150, and replaces those two with a 150. Okay, so let's see if I can move this over. Okay, and then this is before the push, and this is after the push. Okay, so the push, VSP should be 1 higher after the push because it's now the new top of the stack. Okay, and the virtual PC, it would be it gets incremented when it gets executed. So actually, the virtual PC starts here, and now it needs to end at the instruction following. So it needs to, it increments. It grabs this instruction in increments, so that the VPC is ready for the next instruction. But this is actually a kind of a parameter. So when this runs, it should update both the VSP and the VPC, the program counter. Okay. I hope that makes sense because that's going to be kind of the test. We'll put something, actually, I don't even have to have anything on the stack. I just have it pointing somewhere. And then we'll check that it's 1 higher. And check that the VPC is also 1 higher. Okay. So, let's see. All right, let's make this into a test. So I just copied this. This is, pushes 1 item. Okay. So we're going to branch to the push routine. Now, I think in the language, this is an interesting case. I think the statement is really, the statement is 142. And then we compile it into this push 142. But I think you don't really say push ever. So I'm going to put an underscore in front, kind of a convention for more private-y kind of things. And we'll use that fact too. So I'm going to branch to underscore push. We need to we need to load up the VPC and the stack pointer. Okay. And this is where I think we can do this here. This is the push test stack. And we don't need a lot of room. Let's just say, actually, I don't know what we need. Let's do quad, and we'll put some empty stuff in there. Just 4 words. Okay, and push stack will point at the first one. All right. And then let's do L data is a quad 142. Okay. Now, I think that gives us enough. I'm going to ignore this 8. We're just going to start VSP at that address. So I think we can add address relative L push test stack goes to x19. Yeah, usually there's they call it constant. I decided I would call it push. Um, and again, usually you just have the number sitting there. Most fourths let you do it in hex or whatever base too, but hex or decimal or whatever. But I'm not going to worry about that too much, but I will worry about just being able to push something. So yeah, I think this is the same as constant in fourth. All right, so we'll load up the push test stack in x19. We'll load up the VPR, virtual PC in x20. I'm really wishing for my macros. I don't know if I can I define a macro? Let's treat that as a refactoring. Okay, so L data, load that into 20. No, that's not right. That gives me the address of that data, I think, right? So I guess I am okay. I don't want the 142. I want the address of L data. Okay. So if we call push with that stack pointer, okay, then all right, then we should see the stack pointer should be bigger. Well, this is I'm going to work on this assert macro too, I think. I think we can do that. Okay, so I want to compare three things, I think. Health data. X20 is the virtual PC. Let's just put a 1 here after it. Okay, so I want to say, okay. All right, I'm going to make sure the VSP is 1 bigger. Well, 8 bytes bigger. And I guess I need some temps to do that. Okay, so let's move. No, we'll load X 3 because we're not using that otherwise. 3 is going to be L push test stack. Okay. And then we're going to add X3 gets X3 plus 8. And then we're going to move that. Well, I guess we could just do that in X1. In X0, I mean. Maybe this is just X1. We're trying to get the expected value. We expect it to be L push stack plus 8, which gets us there. And then X0 is X19. Okay, so X19 is the stack pointer. X1 is now the push test stack plus 8, which should get us to the second word. Okay. I'm going to put the dead beef in here, just like don't touch. Okay. Gets us to the second word. X1 is now X1 plus 8. Okay, so this is VSP. I guess we won't expect it to be stack plus 8. Okay. Oh. Thank you. Yeah. Okay. So load the current VSP, load the expected value, which is the current plus 8, and check that they are equal. Okay. Now, I think we're going to do this incrementally. Or do we need more? Each assertion needs its own label. Ugh. I don't know. Yeah, let's make that L VSP update is ASCII Z. And I saw some places using this all in one line like this, and I'm trying this on. We want to say VSP should be incremented. Okay. All right. And then, okay, now, so VSP should be incremented. VP should be incremented as well. I've got memory going both ways, don't I? Let's swap. Okay. Try to keep the addresses flowing in the same order. Okay, so the VPC should be incremented. Well, it should be one further than it was. Okay, so move x0 gets x20. X1, we're expecting the data pointer to be L data plus 1. X1 gets L data. Add X1 with X1 plus 1. VPC update. I don't know why these are indented. Okay, VPC update. ASCII Z VSP should be VPC. All right. I guess I should put the other assert in here. It's still about the stack. Okay. We're trying to load. I feel like I'm working too hard to get things loaded, but I want to see the test data stack. Do we just do a plain load? I guess we're not. Okay. Let's move. No, let's do an ADR. ADR L push test stack goes to X0. Gosh. Let's see. Is this thing going to demonstrate this? No. We had loading memory. Yeah, chapter 5. I think he does byte loads, so it's going to be a little hard to... Yeah, this is the example we looked at before. We get those addresses. Loop is until byte pointed at. Well, let's load relative B. That gets the byte? Okay, I think we're going to load X0 gets indirect X0 to get that value. And then that loads the value in test stack, and that should be X1 should be 142 now. And then address X2 L stack update. Okay, and BL assert equals. Okay. Okay, so X19 is the stack pointer. Okay, so the setup is we set L0 gets the empty string. That seems left over. Okay, we're given a PC, a stack pointer and a PC, virtual PC. Okay, we do the push. We expect it all to be on there. All right, and then I think I'll make another. Okay. This should break, or at least not come. Oh, shoot. Don't do that. Okay. And then dot slash. Oh, we need to get core tests in the make file. Core test dot int depends on macros as unit dot macros and core test dot s. And then we have to do this. I think we're working too hard here, but okay. And then core test dot out. Tests dot out. I gotta fix that. Core test dot out depends on AS unit and C like because it prints. Core.o because that's what it's testing, and core tests.o since that's the tests. All right, and then we do this. Tab. Okay. Core test depends on those things. Core test.out depends on those. And then clean will cover that. Okay. And I guess this is sort of a different section. Okay. Let's do a make file 15. Well, that seems okay. Let's see, I misspelled that. That doesn't seem like a missing separator to me, but okay. 15. That's a tab. Is that line? Did I not hit save? No. Okay, let's take out line 15. LD minus O dollar at and right to dollar great apparel. Just like the other one. I don't see the difference. Core test that out depends on AS unit. Make sure these are all spaces. Tab. Tab. How is this not good enough for that line? Yeah. Evil magic. So, what the heck? Core tests.int. Where's my int? What? Oh, core test.int .o from .int is a symbol. Oh, wait a minute. That's happy. ASUnit.o, select.o, core.o, and core tests.o. Select tests.o. ASUnit selike core because we're testing it. That's only testing selike. Core.o gets created. Core tests, do I not have them? No, I do. Depends on core tests. .o.int. Well, I don't think it's going to like this file any better. $arrow. You're supposed to have a blank line at the end, I think. What's the... Line 15 missing separator. I don't know if there's other hints from make. All right, so if I take this line out, he's happy. What if I say %.out depends on %.o, and you handle it by doing this. And save. select.o depends on select.s. So I think that's getting built. I mean, I could do it the same way. Now it seems happy. Okay, it builds ASUnit. It builds select.int into select.o. Builds core.s. Builds unit test demo. Loads unit test demo. Builds select tests. That seems like a, no, it's sea lake. Okay. Yeah, so, oh, I've left off my core test dot out. Left off it. I don't think that should have broken anything, but I should get them all now. Why is that space in there? It's on AS unit. Okay. Make clean. Make. Well, I'm sure I did not mean ACR. Unknown token. Doesn't like that there. Okay. Core tests. ACR. Sure enough. Okay. Didn't like that beef. Let's just put a 99. Okay. Ugh. Empty string length. Oh. Pushes one item. Undefined symbol push. Okay. Yay. I don't know what's going on there in that make file. It seems weird to me. Like this is why I did that there, maybe. I don't know. All right. We're missing push in core. Well, let's get core tests. All right. Push. Okay. We'll leave the table there. This is underscore push. He calls nothing, so he's fine to just do a return. He doesn't need to do any stack pushing because he doesn't touch the stack register. He doesn't call subroutines. Certainly not now. Okay, so this should run and fail now. Oh. No, we didn't make it global. Pointer not aligned. We didn't have that error a minute ago. Core.0 18. Well, let's try our obj dump. Core.0. I had a parameter on that the other day. I forget what it was. I guess I better look. Obj dump. Minus D. Okay, 8 is UDF pound 32. Where's our dead beef? Pound 32. Undefined. But this should be 12 is 0C. 20 is no. Table push. Okay, I mean, our code looks okay. Maybe a line 2 is not enough. They were a little bit ambiguous in the description. Let's... But it's not UL. Let's try 4. We'll have to figure out what it all means, but just to get through this piece. Okay, something's going on with the lines. All right, we're ready to run core tests. .out. Push is one item, fail. Fail, fail, fail. But it, why did it not? Well, I was expecting 3 failures, but I was thinking we would get the strings. I don't know if this is the same issue. Push pushes one item. Okay, the test writes that. Let's go back to the select tests. LTS empty string length. We gave it a label. And I don't remember what assert equal does even. Prints the fail message. Well, I don't see anything about x2 in there. It has no function. Okay, that was some earlier stuff. All right. For where we are now. Okay, so core tests. This does nothing. We changed around. Okay. So fail, fail, fail is good news then. We just each one of these just prints a fail when it blows up. Now, I don't think that's ideal, but that's what we have. Maybe something we should fix, but let's get this going. All right. So I think we will core.s. So the first thing was it's supposed to well, it's supposed to put some data in. The data is at that VSP. All right, so we're going to have to get that. And I think that's, assuming I did this right, load that. That should get the data for us. We're going to put x0 gets x20 is virtual PC. Okay. And we're going to increment that by 8. And make sure I got my notation right. I want to do post increment. Address mode. Post indexed inside and outside. So it looks it up and then it adds. Okay, so I'm going to look up whatever's at x20, the PC, increment it by 8. Then I'm going to move. We haven't done a store relative yet. Is that str? I don't know. Well, there's str. Okay. We're going to store what are we doing there? W5 store character to output string. X3 is the address of the output string. So that's what's getting incremented. Store X0 contents of X19 add 8. Okay, so we take the contents of the virtual PC, we take the virtual PC, we load indirect from it because it points to memory. We get X0. Then we store X0 at the current stack pointer and increment that. Okay. I think that seems right. Takes a lot of tests to assert it, that's for sure. Okay, we'll make, and then we'll run again. Bus error, okay. Ugh. Wow. Okay, we're going to practice our debugger again. Find out which line blows up. And let me look. Breakpoint set. I don't know how we did this the other day. Can we set a label? No, that'd probably help. Can we set it at push? Wow. Okay. Well, we can make an expression. I don't know if B will help. There was N. Let's look at core.o. Okay, let's try a location. Was it address, lowercase a? First we'll try it with a name. That's not going to do it, is it? And we're looking in the wrong file, I think. Pushes this. What might I say? Okay. Now I think this, I should have done this. bd dump minus t. No. Can't do it for output files. Okay. Ooh. Right. So I hope we have a breakpoint for push. And then was it just run? Okay. str x0 x19 pound 8. So does that mean it's the load that blew up? Did our test should have said x20. Yeah, tail data. Well, oops, sorry. Let's back it up. Pushes one item. No, that's not it. Was it it? Pushes one item. Boy, there's a lot of other stuff coming in after that, isn't there? Okay, so pushes one item. Guess I can keep this here. We got our store, we got our address. There is a next instruction is step over. And I thought there was a way to dump the, register read. Okay. X20, core test.out start. How is that possible? Well, that's our call. I guess we don't control what X20 is because it's caller set. Oh, well, let's try that. Oh, yeah, okay. Um, how do I do a next instruction? Target. Oh, step over. I guess, what am I trying to learn? Yeah. Um, I push, branch to push. Right. Okay, that's text. That's our test entrance. Okay. STP, this stuff is probably just data. Red. No, where's our test? Branch pushes 3DE8. Oh, there's our no op. Okay. X19 gets 68. Oh, so I don't know what the second column is. Must be the contents. Yeah. Okay, so 68 plus DEC. Do I keep my calculator up? I did not. But it's supposed to be our stuff down here. So it's got to be that. Okay. Let's do step over. I don't know if this means I'm supposed to type an O. Nope. Control O. Nope. Commando. Nope. Oh, Command V. Lowercase v. Can I just do that again? Now I want to view registers. Oh, let's see. Well, can we help? I'm not. There it goes. R. Okay, there's got to be an exit. LLDB F1. Exit. Hey, Tooks. Welcome. Well, X20 still looks like core test.out. Or start. I don't know. I mean, the VR stuff has suffered every time it's tried to come out and do anything. $3,500 plus is a lot of money to find out. It looks cool, but I don't know. String length. I think I've screwed up again. Yeah. I don't know where that leaves us. It looked like I think we got to here, but it didn't look like X20 had what I expected. Ah, it's so painful. Okay. I don't know if I can. I guess I want to stop at that same. Okay, if I run again. Yes. Okay. This is my breakpoint in start. Let's continue. Oops. No. Well, let's get me that. Just continue. Okay. Okay, we're at core tests push. Oh, we already died. So we printed the name and we're stopping at str. Okay, now can I look at register? Oh, it did change. Okay. Oh. Should be 64. I got to make sure I've got the terminology right, but I think quads are 64 bits. We had a link. Assembler directives. Yeah, for each big number, it emits an 8-byte integer. So 64 bits. But, okay, so now we got start plus 184, which I suppose is okay-ish. If we... All right, let's dump... Now we can just look at the one file, obj dump d core.o. Oh, it's start. No, we got to look at the out. Okay. Okay, let me get the calculator back up. Okay. Start. Okay. Plus, I think it's 88. OX58? No. 5 times 16 is 80. Yeah, I think that was right. 3DF8. 3DF8 is push. No, it's an instruction. Let's see if I can do this. 8, no, 10. Okay, so if this is 144, whoops. 144 base 16 should be 90 plus that is 3E30, which is in here, which is the 0 beforehand. Oops, sorry, I lost your comments. Yeah, this back and forth is going to kill me. All right, well, I think that's telling me 144 is this, which is the 99, which is, I put that in the stack so we could look at it if we needed to. But 30 is the stack, is in X19. Okay, that's good. And then 40 later, well, 40 decimal is 2 is 30. I guess it's 28 later in hex. 184. Well, 40 should be how many? Five words later. So this 1, 2. I think we had 3, 4, 5. No, we wanted to get to 50. Let's take this. Clear. This. No. Copy. Paste. Minus. Let's find start. This equals B0. Turn it into decimal. 176. Yeah, I mean, I don't want to underestimate them, but gosh, it's just, well, I guess it's no worse than it was to jump into the Mac when it first came out, 3,500 now versus then. I don't know. All right. Ugh. Well, I would say it's encouraging that it's there. 40 should be 5 words later. Let's make sure that how that looks in our code. If I can find it. Core.s. Okay. Nope. Core tests. If this is 40. Oh, it said 144. If this is 144 plus 8 is 152, 160, 168, 176, 184. I don't know. All right. Well, tell you what. Let's take a break. Come back and finish debugging this, I guess. See you in a few minutes. All right. Welcome back. So the error we got, bad access 3.0. LDB unnamed symbol 11 plus 92. The only thing I can think of is alignment again. And, we did say something about align. Let's see, where'd that go? I noticed the example we have is using P2 align, where 3 gets you to a multiple of 8, which seems like kind of a bare minimum. Is really, I don't know. Seems like it should be more. Okay, somewhere I read this. Yeah, inconsistent. So that doesn't really tell us what we've done. The first expression is the alignment required. Okay. A multiple of 8. We don't need 2. Low order bits align 3, advances 8. So yeah, we don't know if we should align 8 or 3 or what. Now P2 align. That definitely tells you the number of bits. Okay, so well, what's he doing for those? I think it's got to be 3 or 4. He does 2. Does that seem like enough? Well, what it inspires me to do, 4 bits is 16. It's like so confusing. P2 align 2. Well, I guess what I'm wondering is if we are out of alignment here. You know what I'm going to do? I don't know if this would be a good thing or a bad thing. I'm very tempted to... Whoops, where's core? I'm very tempted to pull our code in. I keep looking at the wrong one. Pull our code in. Okay, let's see what this .p2 align 2. Let's get those used. And in our tests, oh, I never did that here. Okay, and then here. We're just going to remake ./core test that out. Okay. Yeah, I don't. Yeah, maybe it's too desperate. All right, maybe what I got to do is let's pull this action in. So instead of BL push, I'm just going to do the code directly in here. Yeah, I'm just going to do the first one for the moment. BL push. Okay, so let's do this and this. Oops. Okay, so all we're doing is our remote load, and we're pulling it into one routine. So what is this? Kent Beck has a name for doing this. I forget what he calls it. But you basically pull stuff in, and then you can delete anything after the stuff you haven't got through. So, gosh, blanking out some sort of football name. All right. So we've done this. The one thing that should be true is this should be +1. So I'm going to move this assertion up. Okay. So when I get here, x0, x20 should be bigger. Oh, well, 1 is wrong. That should be an 8. Okay. All right. Let's do the LDB. And I guess we got to dump our core tests again. Okay, we want to break in our test unknown. Oh, that's text. Where's that no up? Okay. X1968 BL push. I don't want to do that. Did he rebuild? Okay. Make should pick that up. Core test out. Pass, fail, fail. Well, that's a good question. I believe you are with ARM64, and I believe you weren't with ARM32. But it's often the case that the text segment, which is where the code gets put, on many architectures is not allowed to be written to. It's kind of a shortcut, because if I put that in a data segment, it can be relocated somewhere far away, and I have to reference it with a more complicated set of instructions. You know, we get to that page and offset thing that we haven't done for ourselves yet. But okay, this incremented our 20, the 20. All right. Which is good. All right. So that moved forward the way we expected. Then the VSP we didn't touch. So, but that's the instruction that failed on us before. All right, let's just make sure our print. I mean, our print uses X28. It doesn't use those others. All right, well, now I'm going to do this. So we expect the stack to move, and this is expected stack contents. Okay. I guess that's original. All right, so let's run these. Make okay, it's something about the stack pointer. All right, so the second instruction is the one that blew up. L push test stack is on L19. And he looks like he's loading an address, right? So he was plus 60 something. Okay, so the contents, well, the contents ought to be 142. Okay. Code 1 is for read. When you say code 1, which one are you referring to? I mean, maybe it would be better to put this in the data segment anyway. We'll default back to text. Bad access error. Well, bus error. Did we get another code before? Oh, there's the code too. Okay. For write error. 3E30. That seems like the right address. And that was the address we had there. These are quads. These could be screwed up, but we don't reference these. I mean, a quad should come on an even boundary because you don't really like to pull across. Maybe it's not even allowed. I don't know. Okay, so if it's the right, then this address got looked up. Oh, now if it's data, it's going to be wholly different. Okay, I want to push on this a little more this way. Okay. Um, okay, that says core tests. Okay. Now I'm going to put this back. Make sure. Okay, so it is the store. I mean, it's the store instruction, and like you say, it's apparently a right error. So the X19, well, it sure seems like if X20 gets L data, then X19 should get L push test stack. Not much problem. Um, well, X19. Is this really? Let's make sure this is. I don't have them backwards. Store register. The register to be transferred. Calculate an address from a store and immediate offset. I wonder if I'm not allowed to do increments on that. Because the extra amount is a shift value. And I think we've had another example. Well, no, this one looks like it's doing that. Store byte. Seems like we had another example where we had an addressing mode that wasn't allowed by that instruction, but the assembler didn't really complain about it and just let us do stuff. Let's break it up. No. But now we can find out if it's this line. It is not. Okay, now your theory is, I mean, one theory is, like you said, maybe it's just not even allowed to write to this text area. But we've done it before, or maybe we haven't. Maybe we've only read. Okay. Let's try 20 here. Like, how should it matter? I don't think it should. Did I save? Yes. Okay. So it's not anything special to X19. All right. Data. That shouldn't be needed, but maybe here. Okay. Now this is in the data segment. I hope it complains because it should. Yes. Okay. This is good. It can't load it with ADR when it's in a different section. It only loads in the same section. So this is kind of closer to what we have to do anyway. And I think the example, he does this. He does ADRP. And I think that's the kind of thing we're going to have to do to get to INSTR down here is in the data segment. So you have to do a 64-bit load basically because you don't have 64 bits in your 32-bit instructions to specify the whole address. So it doesn't matter for the data, but it matters for the stack because it's writing. Okay, so we're going to say ADRP X, I guess 19, X19 with L push test stack at page, and then we add, goes the same XOR X4 insert at page off. Now I'm going to leave this one in the text segment just for, I don't know, stubbornness. ADRP X19 loads the page, add the page offset, and then the data is fine where it was. Okay, and we'll just go for it. And then see. No, come on. Add X19, L push test stack. Oh, L19, L19, X19. X19 equals X19 plus the offset. Okay. ARX1 L push stack. Oh, same thing down here. Yeah. We'll load X1. X1 gets X1 plus that. And then it also gets plus 8. Okay. I think I probably got one more. So this goes away. 060 push to stack. Okay. Okay, good call. Oh. All right. So yeah, I think what we're seeing is you're right about the maybe it's that you can't write in those text segments, and we just have never written to them before. Um, in a way, I don't feel bad because the stack pointer in real code, production code, the stack pointer is going to be along. I mean, it's going to be a data segment reference anyway. So we solved that problem. All right, now I should be able to just call push. Well, let's take this out. Call push. Only I'm going to push. I'm going to give it the same instructions we had, which broke up that str. So we'll find out if those. Bad guess. We'll find out if this auto increment, post increment thing is valid for a store. Yeah, I suspect it is, but okay. Now we'll go back to it. So now we're doing it with the #8s by analogy with load. Okay. Oh, well. That's a TIL. Let's keep track of that too. Oops. You can't write values to the code segment, and then prefer.p2 align to and to load or store an address. I need a bullet for this part. Let's load P. No, header P. Okay. Good to know. All right. So, a lot of pain for 2 lines of assembly code. Well, 3 we returned. Okay. Now, golly. Let's see. Well, let's make let's do our add. Okay. I don't think that's a wrong thing to do in the circumstances. Okay. So we load up the stack pointer, load up the data. Okay, and we call push. All right, we got the data. Well, let's do 58. That was just a junk value. Okay, so now I believe we can do this twice in a row. And that should push two values on the stack, the 142 and the 58, because the program counter will have bumped each time. Okay. And then the thing we want to do is add. I don't know if the case matters or not yet. All right. So our add routine, yeah, make a stack macro. Maybe that would be good. You know, really, I don't know. Like, how real do I want to be? This X19 is supposed to be kind of a global for us. I mean, it really is like pseudo processor state. All right, where'd my to-dos go? Let's update that. We develop push. Okay. And then add primary. Okay. Yeah, let's do it twice and then make that macro. Okay, so if I call add, I expect the VPC to, well, I can say be plus 16. Okay, because it should have incremented twice. 8 bits and then 8 bytes and then 8 more bytes. Okay, so we load L data. We're using the same data for the two tests. Then we're going to take the stack and make sure it's the original stack plus 8. So there should be one value on the stack like there was before. And then we'll check. And then the value should be 200, being 142 plus 58. Okay, this should complain that the method isn't there. Okay. Oh, and I should change my test name. Add A plus B. Well, it's really B plus A. And A, B, C are pretty much the standard names for the top three things on the stack. A is on the top. Is A. Yeah, no, I agree. I just wanted to do it a couple times and then put the macro in. Maybe I don't need to. Maybe we've got enough information here. All right, let's do it. Macro init stack. And I guess we'll take a location. And maybe I got to say data stack just to keep my head straight. And I'm using capitals for the macros. I don't know if that's a good convention or not. This is location. Okay, and then I'm just going to make a add return just locally to get it going. Did I use? I think this. I'm going to treat this as always loading to our global VSP virtual stack pointer. So I think he's okay as this. But I really would love a global substitution for 19x19 to be VSP. That might be worth the trouble. I did look at X4. I mean, I brought up the page and I never really read enough to figure out what the strategy was there. And there's an equate in assembler directive. I got those over here. But it didn't take registers for whatever reason. And set. And they don't have a there's no examples. We may try again. Otherwise, I do think we're doing enough to do a macro language kind of thing. All right. So this should well, it should return with a failure, I guess. Undefined symbols. Core tests. Oh man, do I have to do all those at once? Because we have a start. Now I thought pulling the data segment out put it on a separate thing and didn't care. But I'll put it down here. Don't know why it puts those in. Okay. Start arc from core test.out. Core test.o. To core test.out from core test.o. Undefined symbol referenced from. Oh, so let's say location. Oh, I didn't do backslashes. Well, let me undo this junk that I did. And I guess I'll look at these macros. Yeah, just backslash. Push test stack not found. Oh man. I forgot to save my commit. Okay, save, make. that out. Okay. Um, so I guess the test passed because we. Oh, wait. What just happened? I didn't run my other test. That's an easy thing to forget. Okay, BL this. Well, actually, I think not doing it. And let's commit this. Um, this was get push to work by moving writable data to the data segment. Okay, now this. Fail, thank you. All right. So what has passed? The VPC got incremented properly. Does that seem right? Was it pass, fail, fail? Let's see. Up here, the VPC got incremented by 8. Oh, I see what you're saying now about the stack load. Okay, why did this pass? Oh, it shouldn't be. It should be 8. If I did it up here, it should be 16, but now add should only leave 1 on the stack. Okay, so everything fails like it should. Good. Okay. So, yeah, let's make this macro. Yeah, we don't have to do the comma there. Let's do register location. Well, this is really like a load. It's more like a load. The fact that it's X19 is not really so relevant, is it? So replace this with load data. Whoops. Replace all. And this is X19. X19. And then this one is X1. Okay. And this is the same, except for X0. Okay. Fail. All right. I think we do. It should be the original +8. There should be one thing net added to it. Or you're talking about this one, but I think both of them. Oh no, this one should be 16. The other one should be 8. Okay, because we're pushing one thing on the stack net. All right, so it should be +8 +16, and then add should take it back down to 8. All right, so add, I think it's going to be, what does he have to do? He loads the PC because he's getting it from there, but we want to load the stack. Okay. So do we need to offset it? Well, I think I'm going to make this x1 is B. And then after you're done, -8. Okay, so we'll take whatever the stack pointer points to, except that's the VPC. The stack pointer points to, load that to x1, and then decrement. And then I think we do the same thing for x0. And decrement. So that's 2 pops. And then we do an add. X0 equals x0 plus x1. And then we do a store. And again, I want to steal this. Store the value we want to store to a push. Okay, so we're pushing the result. To remove the address increment when I change the macro. I believe I left the instructions there. Yeah, it was 2 increments before because I kept the add 8 separate from the add loads add. So that gave us the original pointer, but then I wanted to increment it as a separate thing. Yeah, let's see if the test passes. All right, make. I don't know if I did a full save. Okay, make. Oh, close. Okay. Now this is where our assertion would be really nice if it told us what the problem was. It was not 200. Well, make sure we're getting it right. Load our x0 contents of x0. I don't know, is that... No, x0 is... I think this has got to be -8. The stack points where you want to write next. So add should pop A, pop B, which is the new A, B plus A, and push it back on the stack. But I think the problem is the stack pointer points, where does it point to the current? I think it's pointing to the next place to write. That's probably not what we want. But so with this, I'm saying go back one on the stack, and you should find the 200 there. But then I think we'll need to adjust this tomorrow. Okay, so I just changed that to a -8 to get one more back. No. Okay. Well, I guess we'll debug it tomorrow. We're close. I mean, something's happening. Nothing core dumped, at least. That's progress from the first one. I think we'll need to straighten out. Make VSP point to the first element. Okay. Not the next place to write. Okay, I think that'll help. All right, well, we'll pick up tomorrow, 2 to 4:30 Eastern, 7 to 9:30 p.m. UTC. We'll see if we can get this ad done relatively quickly and go on from there. All right, thanks for joining. Take care. Good night.